characteristics. So we begin with span. So it says that if in a measuring instrument the highest point of calibration is x2 units and the lowest point is x1 units. So what we are trying to say is that the instrument has been used between 2 points. So the instrument has been calibrated to work between 2 points, right? And this is so this is x2 and this is x1. Then the instrument range is x2. It is the highest, so it can work up to that value, and the span is x2 minus x1. So if this is 200 degrees centigrade and if this is minus 40 degrees centigrade, then the range is 200 and the span is 240, right? So that's pretty obvious. So we have to remember these two details. Next, let's talk about one of the perhaps the most important parameter called accuracy. So accuracy, if you see instrument specifications, they will be generally written as accurate to within X% of either reading or span. You know, sometimes they say reading, sometimes they say span. In fact, sometimes they also mention constant values, that is accurate within plus minus 1 degree centigrade. So if when this constant value, then since the span is a constant quantity, so you can always express it as a percentage of span also, right? So if the span is 100 degree centigrade, then an error is of plus minus 1 degree centigrade can be expressed as 1% of the span. So it's either a constant value, it may be expressed as a percent of span, or it is a percent of the reading, okay? So what it means that if a reading is 100 and if it has plus minus 1% of, let's say, span accuracy, then the reading is somewhere within, let's say, 99, and then the true temperature will be between 99 and 101 degree centigrade. And this, so at all points, so whatever reading you get, you can always, basically these are needed because the user of the instrument needs to know that within what values, so it gets a reading, but within what is the guarantee that the true value will be staying within certain limits. So that limit is stated by accuracy. But then again, the true value is unknowable, and it is actually what is stated is that with respect to the calibration. So then the next point is linearity. You know, we generally want, although instrument calibrations will not strictly follow a linear curve, but still it is very useful to imagine the system as a linear one. So you know, if you have so that you can very easily interpret the true value. So if you have an instrument sensitivity of, let us say, 10 millivolts per degree centigrade, then if it gives a 25 millivolt signal, then you know that it is that the temperature is 2.5 degrees centigrade. So you can get it just by dividing by a number or sometimes adding another number to it. So it is from that point of view, from the point of view usability, it is very attractive to express the characteristic as a linear one. But then it is not linear. So therefore, while you mention a line which can be used for deducing the true value from a reading, you also have to give some bounds within which the true value will remain, because it is not exactly going to, because the instrument does not actually follow that line characteristics. The line is only an approximation. So when you are telling the user to use the approximate model of the line for simplicity, you also have to tell him what is the kind of error that he or she can expect if she uses the linear model of the instrument. So that is given by the measure of linearity. So the linearity specification indicates the deviation of the calibration curve from a good fit straight line. So now how do we obtain this straight line? We can obtain the straight line in various ways. So one way would be this, that you actually perform some calibration experiments. So you got these data points. So you got these data points, these are experimentally obtained. So for all you know, the true characteristic of the instrument, let me use a white color, that will be good. So for all you know, the true characteristic of the instrument may be like this, and you are approximating it by the straight line. So you have to also say that while if you use the straight line characteristics, then the true value is going to be within which limit. So that's why when you say linearity, actually the linearity specification is actually a non-linearity specification, in the sense that it indicates deviation from linearity. So it is defined as a maximum deviation of an output reading from a good fit straight line. So obviously you want that. So obviously you want that the straight line, that the linearity specification is small, so that you are telling that if you use that straight line characteristic, you are not going to have much error. That's what you are telling to the user. So that it is the smallest possible, you have to actually take all the data and make a best fit straight line such that the sum of square of errors is the least, or something like that. So that's linearity, that it is the deviation of the calibration data from some good straight line which you have obtained either by data fitting, or in some cases it may be obtained also in a different way. So for example, in this case you can also obtain it, that's a simpler way, by taking the reading at the least value and the maximum value, and then simply assuming that the characteristic is going to be like this. Now this is not the best fit line, probably for this curve the best fit line would have been like this. However, in some cases you can perhaps use this line, that's actually a simple thing if it doesn't matter. So basically non-linearity, whatever is the line, once you have fixed the line, the non-linearity is actually this deviation. So here it has a maximum deviation. So the non-linearity spec, or which is, we actually refer it to as a linearity spec, is actually deviation from that line, right? So next we are interested in sensitivity. So sensitivity is actually the slope of the line. So if you have a calibration curve, and then so that will be the sensitivity, and if you have a calibration curve and then get a straight line, in case you have a linear characteristic, it will have one single sensitivity. If it is very non-linear, then sometimes you may also express it as, so you can do various things. You can express, say, let us say 3 sensitivity figures. So one sensitivity figure will apply in this range, the other sensitivity figure which is the average slope of the line in this range, and then another sensitivity figure which will apply in this range. Or you can, so basically sensitivity is the slope of the characteristics. So depending on the non-linearity, you can use multiple slopes on multiple ranges. Sometimes instruments do that. Similarly, we are also interested in what is called repeatability or precision, in the sense that we don't want that today we make a measurement of the temperature of boiling water, so it is giving me some reading. Tomorrow if I take that reading should be nearly same. It may not be exactly same, but it should be nearly same. So when it is very close, if you take multiple readings, if they are very close, then the instrument is said to be repeatable or precise, right?